Assalamualaikum and welcome back everyone. So this is the last topic of ISP 568 where we are going to take a look at the continuation of the uncertainty of knowledge. So previously in first week we have take a look at the uncertainty management, sources and nature of uncertainty, sources of uncertainty knowledge in expert system, tools for managing uncertain information. But then we just take a look at the fuzzy logic throughout the semester. So now we are going to take a look at the Bayesian reasoning and the certainty factor. So you may go through again all of the slide, right, that we have take a look during week 1 so that you can relate back why do we use fuzzy. Right, so for this video I would like to explain on the tools for managing uncertain information. So before this we have learned on fuzzy logic, so now we are going to take a look at another two rules that can deal with uncertainty in expert system, that are Bayesian reasoning and also certainty factors. First thing first, let us take a look at Bayesian reasoning here. So Bayesian reasoning, it adapts the basic probability theory whereby in probability of an event, it is the proportion of cases in which the event occur, or it can be measured as the measure of chance. So most events have a probability index strictly between 0 and 1, which means an event has at least two possible outcomes, whether it is favorable outcome or we can call it as success, or unfavorable outcome or we can say it as failure. So for example, if we throw a coin, right? If we throw a coin, okay, the probability of getting a head will be equal to the probability of getting a tail. So the probability would be 0.5. Then another example of probability is considering a dice. So we determine the probability of getting 6 from a single throw, right? So the probability is getting 6 or not getting 6. In probability theory, one is the conditional probability. It is a probability that event A will occur if event B occur. So it is denoted as mathematically as PAB here, and conditional probability of event A occurring given that event B has occurred. So in denoting conditional probability, it is a number of ways A and B can occur over, right, over number of ways B can occur. Another probability is joint probability, whereby it is number of times or the probability that both A and B will occur. So it will represent it as P, A and B here. Okay, both will occur. So the conditional probability of event A occurring given that event B has occurred equals would be P A and B over P B. If you get P, probability of P A, so meaning that you are going to take a look at event P and B and A occurring over what? Event A occurring. So in Bayesian rule, basically this is the formula whereby you have PAB is equal to PA times PA over PB, whereby PA is the conditional probability that event A occurs given that PB has occurred, and PBA is event B occur given that event A occurred, and PA is probability of A occurring, and PB is probability of event B occurring. So in Bayesian reasoning, we suppose all rules in knowledge base are represented in the following form. If H is true, then evidence will be true with its probability. So this rule implies that if event H occur, then probability of event E will also occur, that is P. So in expert system, H usually represent hypothesis and E will denote evidence to support the hypothesis. So this is a formula whereby we have the probability of the event occur over probability of event occur plus probability event does not occur. So that is why we have here the hypothesis that is negative. Okay. So this is when we have single evidence. Okay, we have single evidence. If we have multiple evidence, we are going to multiply all of the evidence together over all of the evidence plus when the event does not occur. I think it must be quite what they call that confusing here if we don't take a look at the example. Right, so this is the example. So you were given a table here. So this is the final question. So you have the hypothesis whether the day is rain or day is sunny, given that you have played golf or ride bicycle. So you are going to find the probability of day is rain when you play golf. Okay, and the second question, day is sunny when ride bicycle. And last probability is day is rain when you play golf and also ride bicycle together. So these two would be single evidence and this is multiple evidence. So when here, after when here would be the evidence. Okay. So you are going to find this probability of this event occurring. So now let us take a look at P. Day is rain when you play golf. Okay. So what you have to do is this is the formula whereby evidence over H, okay, times probability of H. So evidence H here, EH here would be, since it is evidence of playing golf, okay, so we are going to take a look at golf here. This one 0.1, so that is why it is 0.1 times probability of the hypothesis. So probability of the hypothesis of day is raining, okay, day is raining would be 0.45. Go back to here, 0.1 here, PEH here. Why do we take PEH instead of 0.1 instead of we take 0.7? This is because we are now taking consideration on play golf, evidence of play golf, the days rain here. So that is why we have to take a look at this column and row here, not this one. This one is when the day is sunny when play golf. Another question. Okay, so go back to our formula and then we are going to over it with event occur or event does not occur. Meaning that one is when day is rain with play golf. Okay. While this one event does not occur, meaning that day is not raining. If day is not raining, meaning that day is sunny. So that is why we are going to take a look at event occur but with evidence playing the golf. Okay, so this is when we have 0.7, the evidence of 0.7 times the hypothesis of event does not occur, that is day is sunny, 0.55. So if you calculate, you will get your answer here. Then move on to the second question here. Right, the second question would be day is sunny, but then the evidence now is different. What evidence now is ride bicycle. Day is sunny when we ride the bicycle. What is the probability of day is sunny when we ride the bicycle? So what we have to do is we have to take a look at the probability of the event occur. I mean the evidence here, PEH, okay? So day is sunny, so we have to take a look at this column, right? It is going to be with evidence of riding the bicycle. So what is the probability of riding bicycle here? That is 0.5. So we have to write here 0.5 times probability of the hypothesis. So our hypothesis is day is sunny. So that is why it become 0.55 here. And then over event occur, event does not. This is positive and this is the negative. So this is where we have event occur, meaning that PEH, okay, PH plus, okay, plus riding bicycle and day raining. Okay, so that is why we have 0.6 times 0.45 here. So you calculate this, so this will be the answer. This is when you have single evidence. What about if you have multiple evidence, meaning that you would like to see the probability of day when you play and ride bicycle together, okay? So meaning that what you have to do is you need to multiple, okay, the value of the evidence, the probability of each evidence of play golf and ride bicycle with the probability of hypothesis, that is day is rain here. So this is the formula PEH1, PE2 until PN time hypothesis will be 0.1 here. So since we would like to see on days raining, so we have to take a look at the evidence of play golf 0.1 times probability of evidence ride bicycle 0.6, okay, here, times with the probability of our hypothesis of day is rain, okay, 0.45 over, okay, over event occur does not occur. So meaning that this side, okay, is actually this side, right? So meaning that it is 0.7 times 0.5 times 0.5. The hypothesis, the weather is, the day is sunny. So this one, if the event occur, usually it will take this formula. So you calculate it, so this will be the answer. Sometimes the question will be given this way, okay? So it is the same question, but then you have to take a look at the formula and the table here. So for example, you this is for single evidence, okay? So for example, you have here three hypotheses. Previously you only got two hypotheses, whether the day is sunny or the day is, but now since you are going to have another hypothesis here, for example, this is called I3, meaning that if we are going to take a look at hypothesis I1 here, this is where we are going to calculate of event does not occur. So that is why you are going to have these two. Okay, same goes to our multiple evidence. The only differences is multiplying the value or the probability of our evidence here. So next would be on the certainty factor.